let's dive into, for the new people, and maybe even for the people who haven't been paying attention to the specs so much, what is WebRTC? And WebRTC is a few things, but one thing it is actually a standard. It's standardized for web browsers under the W3C here. There's actually two different standards. I'll go through both of them. And in addition to that, there's a number of Ietf specs, right? Now, and this is just a standardization, right? Beyond that, there's this massive, huge community putting together that we'll talk about in a second. There's a few different parts to the spec, right? The most basic one, and I'll give an example, is just, it's called Getusermedia, right? But it's essentially grabbing a camera, microphone. This actually includes screen share also, but it's actually grabbing media, right? The most basic one. And this is now, it has been actually a candidate recommendation for a while. So essentially the standard is baked, it's done. Now, the other main part of the spec, and probably the more complicated one, it's called peer connection, right? And it's called peer connection because WebRTC is all about connecting peers. And unlike traditional web technologies, which is mostly peer to server, WebRTC is all about peer to peer, right? And there's a lot more, it's a lot harder to go peer to peer than it is to go peer to server, right? And most of the spec and most of the setup is actually around doing that peer to peer communication. Now, most people think of WebRTC, they think of doing sending the video streams that you get from the media capture peer to peer, but it doesn't just have to be media, right? You can send actually arbitrary data peer to peer, and there's a number of applications, within what's known as the data channel that help you do that. And even outside of this, right, there's a lot of other standards and ancillary specifications to do a whole lot of other things, right? So, it's nice that you can capture streams, but what if you want to record them? So there's a media recorder spec. There's a lot of things that go on when you send information over a network in a peer-to-peer fashion, right? So there's a statistics API to help you understand and see what's going on there, right? You can see there's other specs for how to handle screen capture and how to handle capturing media from a canvas, for example, right? So there's actually a lot involved here, and they all work together. But the really good news is it's taken some time, and there's been some changes to the spec, but the core WebRTC 1.0 spec is now a candidate recommendation. It's essentially baked. It's done. There's probably not a better time to get into WebRTC now because there's a solid spec that's not changing all the time, and all the browsers more or less, and we'll talk about some of the exceptions there, but are more or less all on the same page with at least what's required in WebRTC 1.0. So just to show a quick example for the new people of what you can do with WebRTC, the most basic one, and probably what you do in most applications to start out, is just grab your camera and your microphone. So one of the things I want to point out, especially for the new people, one of the best resources to go is actually there's a WebRTC.GitHub.io. If you go to WebRTC.org, it'll bring you to this site. There's a lot of samples, and these are all samples that are maintained by the community that are actively tested and updated all the time, right? So this is definitely one of the best places to start out. So there's a lot of examples here. We'll just do the basic Getusermedia demo. And you can see I load this up. It grabs a camera. We'll do take a look in the console to see what's going on here. And this API is actually relatively simple, right? This is the Getusermedia API. And essentially, you pass it some constraints, right? Those constraints can be relatively simple. In this case, we're just saying no audio, since I don't want to say any feedback up here, and turn on video. You can get more complicated here and tell it that, hey, you know what, I only want to have video of certain resolutions, or I want to have video ideally between a certain set of resolutions, or this spec even goes further to say, hey, you know what, if it's on a mobile device, I only want the front-facing camera, all right? So there's a lot more addition to the spec to the constraints object, but essentially you just pass it some constraints. Then it returns a promise, a JavaScript promise, along with that stream, right? And then you basically take that stream and you attach that stream to your video element, and it shows it on the page, right? Relatively simple. Now, the more complex one, which we won't have time to fully go through today, is called the peer connection, right? And I'll show you a couple things here. Just refresh, right? So in this demo here, the peer connection status demo, we start out, just start, we get our camera, our microphone, right? We can make a call, and then a bunch of stuff happens, and all of a sudden you have 2 videos. Now this, some of this actual demo example can be a little confusing because most of the time you're not going to send a video to yourself within the same page, right? Doesn't make a whole lot of sense, although there are some applications and use cases for it. But most of the time you're sending this video to somebody else at somewhere else. But for purposes of seeing what's going on, we'll take a brief look here, right? And they dump everything to the console, right? So one of the first things to do when you generate a call, and one of the things that makes WebRTC works is actually you need to exchange media capabilities, right? You need to know, can we talk the same codec? Do we have the same video? Is one side doing audio and video, and the other side audio, so it knows what to hook up and how to do it, right? So, and the mechanism for conveying all that information is known as SDP, Session Description Protocol. This is probably the worst part of WebRTC. If you work with WebRTC, you probably hate it. I don't know many people, maybe some of the old school telephony people that have been working with SDP for decades, maybe. But SDP essentially is a text protocol that defines all the negotiation parameters. And you can see that here. I'm not going to go through all that. In most cases, again, this is just for information. The browser generates this SDP for you and handles all this. The only thing you need to do as a developer is figure out how to get that SDP information to the other endpoint that you want to talk to, right? Now, in this case, it's actually pretty simple because it's all on the same page. But in most cases, you're going to want to send that through your web server or a server of some sort to get that to the other side. Right. So one of the other challenges of WebRTC is that it's peer-to-peer, right? So when you talk to a web server, usually it has a well-known address. You know you can reach it because it loaded up your page in the first place, right? You know where it is. Now, when you talk to a peer, it's a lot more complicated, right? Because you don't, because of NATs and firewalls, you don't necessarily know what that peer's IP address is and what the end address is. So there's a protocol and mechanism known as ICE, right? Interactive Connectivity Establishment. And the main thing you need to know about ICE is actually just sends out various different forms of ping packets to try to establish a connection, right? And it does a bunch of this, and it runs in the background, and it tries to figure out how can I connect to this peer, and figures out different ways you can connect to the peer, and ideally picks the best one, right? And if it can't connect directly peer-to-peer, we'll talk about later on, there's some options you can go through to relay that information, right? But essentially, so you see a lot in here, what's known as ICE candidates that go back and forth, right? And these ICE candidates get updated inside the peer connection. But essentially, at the end of the day, that SDP, all that information about how to connect, gets sent to the other side, right? They negotiate, and when they come to a, when it looks like there's a common agreement for how to communicate, which is almost always the case if you're talking browser to browser, then the connection gets established. So compared to a lot of things on the web, it probably is kind of complicated. Just remember, it's somewhat complicated because it's doing things that haven't really been done on the web before, and that's really this peer-to-peer communication. Right? Now you'll see here the code is, and this is meant to be a relatively basic code, but it's a little bit long, right? It's a few different steps. There's a really good code lab. If you go to the Google Code Labs and look at the WebRTC one, it'll actually walk you through this process. Actually, I hope probably our next meetup we'll probably actually just focus on doing the code lab and doing a more technical deep dive. But you can see inside the code here, and bear in mind this code's a lot longer than it would be normally because we're doing both sides of that peer connection, right, with all on the same page. But you can see a few things going on here, like setting the local description, right, that local media information, handling, setting up the peer connection, sharing that information, exchanging the signaling state type data, and handling the ICE connections, right? And then eventually when it gets to stream, attaching that stream to a video element to show it. All right, so that's how you do WebRTC yourself, but let's take a look and see, all right, who's using WebRTC. And the list here is really, really long. So some of the stats that Google gave out just a couple of months ago is that they've seen that just through Chrome, just in 1 week, they have more than 1.5 billion audio and video minutes, right? And again, this is just Chrome for people who opt in to gather statistics on Chrome, and it's just really just one use case, one application. Doesn't include any of the mobile or any other stuff that's going on, right? And this is up 45% year over year. One of my colleagues, an analyst who runs a really great WebRTC resource called Blog Geek Me, he counts, there's probably about 1,300 more, and this is a few months old now, based companies and major projects, right? There's certainly a lot more end users and applications and use cases than 1,300 too. The really big one I talk about a lot is Facebook Messenger. They're really just massive. I think their last count was 400 million monthly active users making use of voice and video functionality. This is just some stats they released just 2 days ago, showing that through September they had 17 billion. Through November 2017, 17 billion video chats on this service, and they're adding a lot of new capabilities. Everything that Facebook does, this is all based on WebRTC. Now, I can go into, there's lots of examples in Google, like Google Hangouts, Google Duo, remote desktop. A lot of stuff that Google does uses WebRTC too, and you start adding them up, and it really is a production grade, ready for prime time application technology that's been used for years already, right? And as developers really get to take advantage of some of these companies that have scaled this up to billions of users already. And I think some of the more interesting things is you're starting to see WebRTC used in real-time communications in general, used in a lot of different types of communications applications. So I like this example where it used to be just you made a phone call and then just like there was one device to do everything. Now communications are really becoming fragmented and broken up today to different types of activities. So if you want to have a one-to-one call, right, video call, you can use like Google Duo to do that, for example. But if you were, if you're like this. If you want to do like group live chilling out there, there's applications for that. There's an application if you're remote and want to watch TV with somebody else that's not local. You can do that. If you're playing video games and want to do real-time audio video and see what your teammates are playing, your opponents are doing, there's Discord. There's an app for that. And Twitch, I'm not 100%. I mean, I do think they have some pieces there, WebRTC. I don't have a lot of details, but you see increasing use of these real-time broadcast technologies, also making use of WebRTC. And actually, Chris Allen over here, when he talks, his company does some of that, and he'll talk about some of those applications and use cases. So really, you go from having one universal application, going from just having FaceTime now to a lot of apps that are using real-time communications for a lot of different use cases. And this is in addition to, you see other apps like playing other social media apps like Instagram, for example, that are adding the ability to do real-time communications, real-time calls to it, right? So this is really, really starting to take off. And WebRTC is not just for fun, for social time, it's also for work. I'd say almost every major business communications platform has some aspect of WebRTC. Slack is one who added WebRTC a couple years ago, right? And they had a team of 6 people, and now they're running 1 million minutes a day. Just as an example of someone who's done this relatively recently, but has a very significant user base. One of my other favorite examples is actually the U.S. government and the Department of Veterans Affairs. Usually you don't associate the Department of Veterans Affairs with being competent at all, certainly not being able to take on something like video conferencing, but they've launched a WebRTC-based video app to do remote telemedicine to users. So I always tell people, if the Department of Veterans Affairs can figure it out, I'm pretty confident you can too, right? And they have 700 million users, right? So it's actually a very significant rollout. And we're starting to see a lot more this, going from just being used inside your smartphone and inside your computer to actually being used inside embedded devices, right? So Amazon is actually one of the first, big users of WebRTC. and they continue to be, and you see them putting real-time communication, streaming, calling into their devices like this Echo Spot. And really, this is just the beginning, right? This real-time communications and WebRTC is being used like everywhere in the home, be it toys and the communications tablets, intelligent assistants. And I think some of the more interesting applications that we don't hear as much about or don't think about as much is some of the industrial applications, like what can you do when you start sticking cameras on robots and in things like wearable technologies. And not surprisingly, WebRTC's been very popular with developers. So here's some stats I pulled actually last October. One of the great resources, if you use Google BigQuery, they actually have access to all the GitHub pulls and information. And I ran some queries and filtered that just to look at active users and active repos so within a given month. So meaning if there was some active push or activity. And you can see here it's just been positive up and to the right, really without a whole slowdown. Just to be fair, I did compare this against the GitHub overall activity here. As you can see, there's a period here where WebRTC actually was pretty far ahead and more active than the average GitHub. But as you can see here, WebRTC is doing pretty well in the development community, and there's a lot of resources and a lot of example code and a lot of big projects that you can work from. And we'll talk about some of those in some of the speakers throughout the talks tonight. So the next big question is, where can WebRTC be used? Right? And we'll start with browsers here. So Chrome and Firefox were very early adopters. Microsoft with Edge put WebRTC inside the Edge browser, and they do support WebRTC 1.0. I'm not going to go into all the caveats of Edge and where you can and can't do it and some things that work. I'll talk a little bit more about Safari because that's new, right? And then the other big one is Safari. They really were the last holdout to do WebRTC, and it was particularly frustrating because especially if you're a mobile developer and you want to make use of WebRTC on iOS, they really made it hard to do with a native browser because one of Apple's policies is they have to use their native web rendering engine known as WebKit. And if WebKit doesn't do WebRTC, then your app can't do WebRTC. If you want to use at least that rendering engine, right? You have to do a native application. You can't do iOS or WebView. And you can see here, I actually haven't updated these stats in a couple months, but I think they're still pretty relevant. These are some of my own rough estimates by looking at some other public figures like StatCounter and doing some estimates of what is the actual usage share within each category, right? And we see there's still a couple holes, things that aren't supported. Microsoft is essentially deprecating Internet Explorer, but there's actually still a lot of users on that. If you do happen to have a lot of users that you need to reach on Internet Explorer, there actually are freely available plugin options you can add to Internet Explorer to add WebRTC there. So there really isn't anything out there that you can't cover. And of course, doing WebRTC with the web is not the only choice. And in fact, if you look at a lot of the traffic and most of the usage of WebRTC, it actually doesn't come from the desktop. It's actually more on mobile devices. And historically, that's not even been mobile browsers. It's been mobile apps, native mobile apps. And Windows now, as part of the Universal Windows platform, has WebRTC built in. And Android has had really good support of all the WebRTC APIs built into their Java APIs for quite some time now. And the next big one that I'll talk about here is Apple with macOS and iOS. So really just publicly launched a few months ago, back in September. Apple added WebRTC to iOS and Safari browsers. So what's included here? Well, one of the interesting things is that they actually took the libWebRTC, the Google source code there. So it's basically using the same core engine as Google and putting this together. And their implementation includes the data channel. It does have WebRTC 1.0 API support. They're using the track and transceivers API, which is a little bit newer, H.264 video. But some of the disappointing things that they don't include here. One is the VP8 codec. And one of the mandatory pieces of the spec for browser makers is that they need to implement both H.264 and VP8 codecs, right? H.264 is probably is the more common codec that's used, that's built into a lot of hardware, but it's not open source. It comes with a license charge. VP8 is free and open source, and there's a lot of debate over this, but the consensus was, browsers should just support both. And then if you have some device that needs to support one versus the other, it's not such a big deal. Well, Apple bucked this trend a little bit. It's not supporting VP8, right? For those of you that are deeper into the specs, Unified Plan is something that Google just announced their intent to implement, because Apple's using, and Unified Plan really is the way forward. There, it's implemented in Firefox, but because Apple is using the Google engine, they don't have Unified Plan yet, right? And you'll see there's a lot of other little caveats and things they don't necessarily have yet. One of the tougher ones is actually you can't grab media sources from within the web view. If you're doing a native iOS app and you want to use the web view to do something, you actually can't get media sources from there. You can take use of the peer connection, you can do data channel type stuff, but you can't actually grab media using that, right? And they don't support other things like screen share, at least not yet, media recorder, some of the more advanced APIs. To be fair, I mean, this is, they've only had it for a few months. It does take time to build some of this stuff. So hopefully they'll catch up. If not, then people will continue using other browsers. I did do a deeper analysis of this. If there's a link there, and I'll send out links to all these presentations and after we're done. So one of the big areas where Safari does, I think, try to differentiate, and does differentiate in some ways, is on the security front. They put a lot of emphasis into privacy and making sure there's user consent and not inadvertently sharing information. As a developer, when you're used to how Chrome and Firefox work, some of this can be a little bit frustrating. Like, for example, they only allow you to capture media from one tab at a time, right? So if you're a developer and you used to send this stuff to yourself, back and forth like what some of the demos are doing, it doesn't work, right? They also don't allow you to do, they have a lot of restrictions for even starting a peer connection without having the Getusermedia consent, right? So this makes it a lot harder to do a lot of data channel and just peer connection only type applications in some cases, right? And also, important reminder on the bottom, if you're want to play in Safari on iOS, right? You need to do the plays in line method there too as part of your video tag. So just to wrap up, I want to, especially for the new people, but I think for everyone else too, I want to talk about some of the newer tools and how do you debug and use WebRTC, right? And there's a number of really good built-in tools into the browser that helps you debug and diagnose WebRTC sessions, right? The most popular one's called WebRTC internals, right? Firefox has something similar called About WebRTC. Unfortunately, Edge has nothing. But Safari actually has a decent set of starting tools. It's not easy to get to. You have to actually go and enable the debug menu, but you have a pretty good set there. Now, there's actually a pretty exciting project that took all the code from WebRTC internals called WebRTC external, written by my colleague Philip Hanka, who helps out with WebRTC hacks, and essentially put the WebRTC internals code into a web extension. And this allows you to run it in other browsers. So you can actually run this currently in Edge, right? So they actually give you a decent set of tools there. And it was working in Firefox, but unfortunately there was a relatively recent bug that's prevented it from working. But it should be back there once that bug is fixed. Right? And another really important thing for the newer developers out there, and even some of the older ones, there's the universal WebRTC polyfill is known as adapter.js, right? You should absolutely use this. This lets you write to the latest spec, latest code, and it deals with all the individual browser differences. Hopefully these differences, they do go away over time, but it's going to take some time before that happens. And especially if you want to easily port your code that you wrote for Chrome and Firefox over to Edge and Safari, really adapter.js is the quickest path to doing that. And before I move on, before we move on to the next speaker, I did want to mention, we've talked a lot about browsers and what's going on, but WebRTC does need servers. There are actually a lot of elements involved here. That's a whole different topic for another day, right? The most basic piece though is a signaling server. Most of the time, that signaling server is the same web server or same communication mechanism you probably have in place already. All right, but there is a number of NAT traversal servers. You hear terms like stun server and turn server that you should definitely have. Those are really needed for production. You might be able to get away with it without using a turn server for your own development, small-scale tests, but you need that. Media servers, if you're doing something more advanced with media, like multi-party video, you hear more about that. And again, Chris Allen will talk a little bit more about that when he talks about Red 5 Pro and what they're doing there. And if you want to connect to the legacy communications world, the old school phones and dial-ups, right? You need some sort of gateway, right? And there's a number of gateways you could potentially get out there too. I don't have time to go through this now, but this was just a rough checklist I actually put together for myself and for a couple projects of a development checklist of things to consider, or at least keep in mind. I'll include this as a reference with the materials.